Welcome to IOQM 2023. Let's see the previous year paper. That is 2023, part 5 of the video. In this video, we will cover 25, 26, and 27 questions. All are 5 marks questions. Yeah, the first one. Find the least positive integer n such that there are at least 1000 unordered pairs of diagonals in a regular polygon. Okay. With n vertices that intersect at a right angle in the interior of the polygon. Okay. Let's first understand the problem. If you consider a polygon where there are two diagonals, the diagonal should meet at 90 degrees. Then he is telling count such uh, polygons. Okay. So once they are basically count such polygons, what is that n polygon side? Okay. Such that you form 1000, at least 1000 uh, 90 degrees intersection. Okay, of the diagonals. Okay, so I have checked actually many reviews of this question, many from the all popular links. I haven't found many of them did not actually attempt this question, and many of them try to attempt, but the answers are not correct. They are getting answer 30, 32 like that, but the right answer is 28 here given by IMO. So I found a solution at Stack Overflow, mathematics Stack Overflow. But problem is they gave a equation which is correct, but there is no information about the derivation of the equation. They gave a link, but I could not find in that link the derivation of this equation for the perpendicular uh, number of 90 degrees intersections. Okay. So to understand this problem, imagine a regular n polygon inscribed in a circle. Okay. Suppose four of its vertices A, B, C, D given give a pair of perpendicular diagonals like this. Okay. Let's take a square. Okay. In a square, you have two diagonals which meet at 90 degrees each. Okay. Right. So that means you got one 90 degrees. You need to find such 1000 such 90 degrees intersection. Then what is the value of the n? Okay. Side of the polygon. How many sides of the polygon? Okay. So here one hint is a regular 2k plus 1, that is odd polygon, don't have a perpendicular diagonals. Okay. If you take any odd polygon, 5, 7, 9, okay, they cannot produce diagonals which can intersect at 90 degrees. Okay. It has to be an even polygon, that is 2k. So for a regular 2k even polygon, the number of diagonal pairs is given as, equation is given as k into k minus 1 whole square by 2. Okay. So this I got from Stack Overflow. You can go and just give same problem, search of same problem. You will get a link there. But he is not given the proof of this one. So I love to hear from you to see this proof of this equation. This equation fits actually. This is the right equation. But the unordered, he said unordered pairs of diagonals, right? Unordered pair of diagonal is you have AB and BA. Both are uh, both are different, right? Now, if you take this equation, we need 1000 such perpendiculars, right? 90 degree intersection. So k into k minus 1 whole square by 2 is greater than 1000, which means k should be greater than 14. If you take 13, you will get less than 1000. 14, you will get more than 1000. Okay. So k is 14, which means k is nothing but 2k is the polygon sides, right? That means n equal to 2k, which is 28. So this is the correct answer given by IMO. And I'm sure this is the right equation to get the answer to this problem, but I just want to know how to prove this equation. Okay, this is really hard. I have done a lot of research to find proof of this equation. Okay, next. In the land of binary, the unit of currency is called ben. Currency notes are available in denominations 1, 2, 2 power 2, 2 power 3. That means in the 2 power n denominations only. The rules of government of binary stipulate that one cannot use more than two notes of any one denomination in any transaction. For example, one can give a change for two bens in two ways. Okay, two one ben notes or one two ben notes. For five ben, one can give one ben and then one four ben note. Okay, or one ben note and two ben notes. Okay, you cannot give um three one ben notes and one two ben notes you cannot give, because three one ben notes you cannot give, more than two you cannot give. Any denomination you can give maximum of two notes. Okay. Now, find the number of ways in which one can give change for 100 bens following the rules of the government. Okay. This looks compared to other questions, it is easy still, though it is you need to understand a lot actually, and it is just a counting problem. Okay. 100 can be written as 64 plus 32 plus 4 in binary notation. Okay. Now, 4 can be given in three ways. Either you can give 4 or 2 plus 2 or 2 plus 1 plus 1. Okay. We did not cross anywhere two denominations. Okay. Now, similar way you have to do for 64 and 32 now. Okay. So, this is simply a counting problem. If you see, you have to be very careful. That's why it is hard. Okay. Now 64 is 164 you can give, 32 132 you can give, 4 all the three. Okay. So 1 into 1 into 3. So many possibilities. 64 can be given as 232s and 32 can be given as 216s. You cannot keep same 32 here because already 232s are there. Okay. So this is 2 into 1 into 3. Okay. Now next is 64 can be given as 32 plus 32 and 32 can be given as 16 plus 8 plus 8. Okay. So that is 2 into 1 into 3. Okay. Mm. Or 64 or 32 plus 32 you take. And here you can give in 16 plus 8 plus 4 plus 4. Okay. So that is 2 into, and here for the 4 denomination you have to remove 4 because 2 fours you have used here. Okay. You have used 2 fours here. So you make it 2 plus 2 or 2 plus 1 plus 1. Okay. So this will become 2 into 1 into 2, which is 4. Okay. You may be thinking, what is this 1 here, and 3 here? Okay. This is the number of ways I can distribute a 4 rupees. Okay. 32 rupees. Okay. And 64 rupees. Here, there are two ways, either 64 or 32 plus 32. Okay. I cannot give 32 here. There is no option, right? So there are three other ways. These are the three other ways. So each one I am individually describing. Okay, this will become actually when you sum up, everything will come into the counting. So that way, the total count is 3 plus 6 plus 6 plus 4, that is 19. This is the answer. Okay. Next, a quadruple ABCD of distinct integer is said to be balanced if A plus C equal to B plus D. Let S be the any set of quadruples ABCD where one is less than or equal to A, less than B, less than D, less than C. Okay, just note down C is the highest number, not D. Okay, C is the highest number, less than or equal to 20. And where the cardinality of S is 4411, find the least number of balanced quadruples in S. Okay, so first total cardinality is 20C4. So many combinations you can produce. Okay, so that is 4845, 4845. Cardinality of S given set is only 4411. Okay. So the left out are 434. Okay. 434 things are left out. Okay. Just note down this. We'll come back to this when we solve the other part of the problem. Okay. Now, if you take A, 1 less than or equal to A less than B, less than D, less than C, less than or equal to 20, the maximum values can be 17, 18, 19, 20. Right? This is the max value. And minimum value is 1, 2, 3, 4. Okay? So we got the minimum and maximum, right? So A plus C equal to B plus D. This is what we have to obey the rule, right? So in the minimum case, A plus C equal to 5, B plus D equal to 2 plus 3, right? Maximum case it is 37. Okay. Now let us build a table to count the possible balanced quadruples. So this is also again one more counting problem only. Okay. Now C minus A minimum is 3, maximum is 19. So you put this restriction and count, then we will get the answer very easily. Okay. So C minus A is 3 minimum, right? So with this we'll get 17 combinations. What are those 17? You start with 1, 2, 3, 4 or 2, 3, 4, 5. Okay. Everywhere if you see C minus A is 3. Okay. Then start with 3, start with 4, start with 17 up to 17. Okay. So your total combinations we have is 17. And here 2 and 3 are fixed. You don't have any other option. Okay. Now for C minus A equal to 4. Okay. You have 1, then 2, 3, 4 are possible for B and D, and 5 is C. Okay, now you check C minus A is 4, correct? But out of the 2, 3, 4, you don't have option to choose any two because A plus C equal to B plus D. So 5 plus 1, 6. So you have to get 6 only from 2 and 4, right? You have to left the 3 out, the middle number out. Okay, so you don't have an option here also. Okay, so that is what this option 1 is, that is what it is showing actually. Do you have an option for B and D? There is no option for this one also. Okay, so again you make it from 1 to 16 here in this case. So 16 into 1, that is 16 possibilities are there. For 5, go to 5. Okay, so once you start doing this, you will start seeing a pattern actually, and we will write based on the pattern. Okay, so here for 5 difference, C minus A is 5, 1 and 6 are the A and C's, B and D are 2, 3, 4, 5. Okay, so in this case, you have any two possible options are there. That is, 5 and 2 are possible, 3 and 4 are possible. Correct? 5 plus 2 is 7, 3 plus 4 is 7, 6 plus 1 is 7. Okay, so you have two options here. That means total number of possibilities into 2. That is what you will get. So total are 15 possible here. So 15 into 2. B and D, you have two options, right? So 15 into 2. So if you see carefully, every time your 17 is reducing, okay, you check for 6 also. If C minus A equal to 6, what you have is 1 and 7 and 2, 3, 4, 5, 6. In this one also 7 plus 1 is 8. So only options you have is 2 and 6, 5 plus 3. Okay. 4 you have to left out. There is no option. Okay. So 14 are the total possibles. 14 into 2, which is 28. So the pattern is basically the 17 is reducing by 1 every time. Okay. And this into multiply with 1, basically B and D values, the possibilities are increasing every every 2 times. Okay. So that way I build the table here: 17 into 1, 16 into 1, 15 into 2, 15 into 2, 13 into 3, 12 into 3, 11 into 4, 10 into 4, like that it will go until the last one. Last one is 19, which is odd number. So you'll have only one option, that is 1 into 9 equal to, that is 9 options. So sum of all this is 525. Okay. So total 525 possibilities are there, but that's not the end. Okay. Total cardinality we know 4845. Cardinality F is 4414. That means all are not included already. So we assume that this 525, some are left out. Okay. How many are left out? We assume that all these 434 are left out. That's what it's trying to tell. Okay. All these 434 are left out. What is the minimum? What is the least number of balanced quadruples in S? That's what it's telling, asking, right? So minimum balanced are part of S. Those part of S are 525 minus 434. That is 91 are the minimum possible balanced quadruple in S. 91. Okay. It can be more, but this is the minimum number. Okay. I hope you understand this includes the counting, and then this is really complex to understand. I mean, 8th, 9th, 10th kids actually. You have to be very careful in solving this. I think this is very hard. Okay. Yeah, definitely hard. Thank you. I'll come up with another video for the last three questions.